Okay, hello guys. We're doing question 10. So let's look at the question. There's a cubical box. There's a cubical box of side L that contains n molecules. And then like each molecule, the mass is m, and they are moving horizontally with speed u to wall A. Wall A is this wall, okay? Yeah. Then when the molecule hits a wall, there's no loss of speed, and they travel in the opposite direction. So like they go in the opposite direction horizontally, like this and like this. Okay. So let's look at part A1, the change in momentum of a molecule when it collides with the wall. So recall the formula, like change in momentum is final momentum minus initial momentum, right? So the initial momentum is, okay wait, sorry, if we take right as positive, so change in momentum is mu. The m is the mass of the molecule, and then u is the speed. Then final momentum will be equals to m negative u, right? Because like it travel like this, then it bounces off, become negative direction. So the change in momentum will be finals minus initial minus mu minus mu will be negative 2 mu. So this is a change in momentum. Okay, wait. Yeah. Then the second one, the time taken by one molecule between collisions with wall A. So imagine there's one molecule, right? Then this is the wall A. Then it travels here, and then it bounces off. So because just now in the question, this distance is L, right? So now it traveled double the L distance, which means the distance that one molecule travel will be 2L. Then the speed they already given is u. So speed equals to distance over time. U speed distance 2L, then time is t. Then if you change the subject, time taken will be 2L minus over u. So this is the time taken. Okay, hi. Now we are going to do part 3. We need to find the force due to all the molecules colliding with wall A. Okay, before that, right, let's recall. The first, like the part 1, we found change of momentum is equals to negative 2 mu. Then part 2, time taken is equals to 2L over u. You see, force normally we say is equals to the rate of change of momentum, right? So if we find force by taking change in momentum over time taken, it will be negative 2 mu over 2L over u, which is equals to negative mu square over L, right? But do you know what this means? Like why there is this negative sign? Because this force is actually a force exerted by the wall on the molecule. It's the force by the wall on the molecule that causes the change in momentum. So but now we are finding the force due to all molecules colliding with all A, which is like the force by molecule on the wall. So now we make use of Newton's third law, and from here you know that the negative sign is taken away because like it's opposite direction, right? So the force by one molecule on the wall by one molecule on the wall will be mass speed square over L. And then force due to all the molecules will be force due to all molecules on wall A will be mu square over L times the total number of molecules, which is n, and it will be n mu square over L. Okay, so now right, for part B, we need to use the answer in A to show that the pressure P on wall A is given by P equals to mu square over V, where m is the total mass of all the molecules and V is the internal volume of the box. So pressure is equals to force over area, right? So from part A, you know that the force by all the molecules on the wall A is actually equals to n mu square over L, right? Then the area of wall A is equals to L square. So pressure will be equals to force over A n mu square over L over L square. Then from here, because like it's a cubical box, so all the sides length are the same, which makes it a volume. Then this nm is actually equals to the total mass of all the molecules. So you can rewrite it as big M U square over V, which tally with the question. Part C, give two reasons why the expression in B is not valid. The expression in B is pressure equals to total mass speed square over volume. Why this is not valid? Because it assumes that all the molecules, they only move in one dimension, which in fact they move in 3 dimensions. So like you recall like this thing, right? The y, x and z, like the particles can travel in y direction, vertically, horizontally, or like coming out of the paper. So like there are a lot of directions that the molecule can travel in. So this question only assumes that the molecule move in horizontal direction, which is the x direction. So this expression is not valid. And then for the second one, right, the expression assumes that all the molecules move in only one speed when they actually move in a range of speed.